Okay, but really, have you ever actually looked at a hard drive? I mean, they're tiny. How do they hold everything? It's like your whole digital life, photos, music, that giant folder you swear you're going to organize one day.
It is pretty amazing how much we take it for granted.
Right. So, in this deep dive, we're going to figure out how hard disk drives, HDDs for short, actually work. And then we'll get to how those newer SSDs are shaking things up.
What's fascinating is they both do the same job, just in totally different ways. Which is exactly what we're going to unpack today.
Totally. Okay, so HDDs, they've been around forever, and for good reason. But how do they actually work?
Well, imagine, like a stack of CDs, except they're made of this special magnetic material. These are called platters, and they're the heart of a hard drive. Picture this. A tiny, and I mean tiny, needle hovering over those spinning platters, barely a hair's width away. That's the read-write head. It's constantly moving across the platters, reading and writing your data.
Wow, okay, I'm already seeing why they call it a hard drive. It's like a miniature machine.
It really is.
But those platters must be organized somehow, right? How does it know where to find anything?
Total precision. Each platter is divided into these invisible tracks, kind of like grooves on a record.
Right.
And those tracks are divided into even smaller segments called sectors. Think of sectors like individual storage containers for your data.
So it's like a super organized library, with each sector holding a specific piece of information.
Precisely. And we're talking terabytes of data. That's billions of sectors on those platters.
That is wild. All that in something you can hold in your hand. Okay, but it's not just about how much data, right? Speed matters too, for all of us impatient types.
Oh, for sure. That's where things get even more interesting. Remember those spinning platters? Well, the faster they spin, the quicker the drive can access your data. That's speed. That's measured in revolutions per minute, or RPM. Higher RPM, faster loading times.
So if I'm the type who hates waiting for my computer to catch up, higher RPM is better.
Exactly. But there's another thing that affects speed. It has to do with that tiny read-write head.
Right, the needle thing. It's amazing it even works. But also it seems kind of fragile.
Yeah, and it is. It's hovering like nanometers above the platter. It's actually aerodynamically designed to float on a cushion of air generated by the spinning disk.
Wait, seriously. Aerodynamics. Like little wings on a microscopic head.
You got it. Just like how airplane wings generate lift. This balance is what lets the head move that fast over the platter without touching it.
Wow, the ingenuity. It makes you appreciate the engineering that goes into this.
Truly, it is remarkable.
Yeah.
But of course, this system is not foolproof. If that air cushion gets messed up even for a second, that's when you get a head crash.
Head crash. Okay, that sounds bad.
Yeah, not great. Imagine like dropping a record needle onto a spinning record.
Ouch. Yeah, that's not going to be good for the record or the song.
Exactly. And with a head crash, that tiny head can damage the platter, which can corrupt your data. That's why you hear people say, be careful with hard drives, don't shake them too much.
Makes sense. It's kind of wild they've been the go-to for so long, with that always a possibility.
Right. It is a marvel of engineering. But of course, technology marches on, which brings us to the rise of SSDs.
SSDs, sleek, fast, dare I say, a little sexy as far as computer parts go, plus no moving parts to worry about. But how do they work without all that mechanical stuff? It feels like magic.
It might seem like magic, but it's really flash memory. Same as what's in your phone or USB drive.
Oh, okay, yeah. So like the same tech that lets me carry thousands of photos in my pocket.
Yeah, click.
But how does it actually work?
At its core, flash memory stores data by trapping electrons. So it's like tiny, tiny switches that can be flicked on or off to represent the ones and zeros of digital data. No spinning, no moving, just pure electronic manipulation.
So instead of a physical filing cabinet, it's like storing everything on a computer network. No more moving paper, you just change values in a database.
Perfect analogy. And that's why SSDs are so much faster. No physical parts to move, so there's no waiting.
Yeah.
It's practically instant.
That explains the speed boost I've always heard about. But there's got to be a trade-off somewhere.
Right.
Nothing's perfect.
You're right, there's always a trade-off.
Yep.
SSDs might be faster and tougher when it comes to, like, physical shocks, but their lifespan isn't unlimited. Remember those microscopic switches we talked about?
The ones that flip on and off to store the data?
Right. Each one has a limited number of times it can be flicked before it wears out. We call those write cycles.
Write cycle. So each time the SSD saves something, those switches flip, and eventually they just wear out. Does that mean SSDs have a shorter lifespan than HDDs?
It's not that simple. An HDD, you drop it, you're done. But with normal use, they can last a really long time. An SSD's lifespan is all about how much you write to it.
So not how many years I have it, but how much I use it to actually store and change data. Huh. That's a totally different way of thinking about it.
Exactly. But hold on. Don't rule out SSDs just yet. They have these really clever techniques to maximize their lifespan and performance.
Oh, this is where it gets really cool, isn't it? There's more going on in these things. They're like mini computers themselves.
Pretty much. One of the key techniques is called wear leveling. So think about it like this. You have a notebook, and you only ever write on the first page. That page is going to wear out way faster than the others, right?
Makes sense, yeah. Go on.
Wear leveling is like a system that automatically spreads out the writing across all the pages, so no one area gets overworked.
So it's distributing the wear and tear. That makes sense. What else have these clever little SSDs got up their sleeves?
There's something called garbage collection.
Garbage collection. My SSD cleans up after me. I appreciate that.
It kind of does. You see, when you delete a file on an SSD, it doesn't actually erase it right away. It's more like marking that page in your notebook as blank, but not erasing it. Garbage collection comes in and cleans those files up for good, freeing up space for new data.
So taking out the digital trash makes it run more efficiently. Clever. Any other tricks we should know about? There's one more, right? And this one might be my favorite.
Ah, yes. Over-provisioning. Sounds kind of complicated, but it's actually pretty straightforward.
Okay, I'm ready. Explain it to me.
Okay, so imagine you've got this, like, hidden storage room in your house. Nobody knows about it but you. You use it to keep things organized, make everything run smoother, right? That's basically over-provisioning, but for your SSD.
Wait, so it's like a secret storage compartment for data, and I don't even get to see it.
Exactly, but it's there.
Yeah.
And it lets the SSD do all its wear leveling and garbage collection even better, even when the drive's looking full to you.
So sneaky, like giving it extra space to optimize everything behind the scenes. I kind of love it.
It's pretty slick. All these techniques working together, they're what make your SSD faster, and they help it last longer. All that, and you don't even realize it's happening.
It really makes you think, you know? All this complicated tech working away, from spinning platters to microscopic switches and secret algorithms. It's a whole hidden world in our devices.
And at the end of the day, it's all about the ones and zeros, the core of it all, how we translate everything into digital information.
So next time someone asks me about data storage, I can wow them with my knowledge of wear leveling and garbage collection.
I have no doubt.
Yeah.
But really, it's not just about, having fun facts. Understanding this stuff helps you make better decisions about the tech you buy, which is what this is all about, right?
Totally. Big time gamer, video editor. Yeah, you're gonna want that SSD speed. But on a budget and just need a ton of space for photos and videos, hard drive is probably the way to go. It's about finding the right tool for you. And now you know how.
And the crazy thing is, who knows what's next? We've come such a long way, from punch cards to terabytes in our pockets. It's mind-blowing, really. What's the next big leap going to be?
Maybe one day it's all going to be stored on a chip the size of a grain of rice. Whatever it is, I'll be here to break it down when we do another deep dive. Until then, ever think about your hard drive as a bustling city?
No, not really.
Well, get ready, because today we're doing a deep dive that will totally change how you think about that sleek metal box sitting on your desk.
Sounds intriguing.
We're going all the way back to the basics with this one, looking at how drives actually work.
From the ground up.
You got it. We'll be uncovering the surprisingly complex world of formatting, taking apart the magic of booting up a computer, and even exploring what goes down when things go wrong in our little digital metropolis. And trust me, this isn't just for tech junkies. Whether you're a coding master or just curious about what makes your computer tick, this is knowledge you can use.
I'm with you. I'm always up for expanding my tech horizons.
Have you ever had a file get corrupted?
Ugh, don't remind me. I lost a whole essay once.
Well, we're going to break down exactly why that happens and how you can avoid a meltdown. But first, let's start with the foundation of our digital city formatting.
Yeah.
Seems simple enough, right? Like wiping the slate clean.
Yeah, you just hit format and you're good to go. Or at least that's what I thought.
Not so fast. There's a lot more happening under the hood than you might expect.
Really?
Oh, yeah. Our sources break down formatting into 3 major steps, each with its own, let's say, quirks.
Okay, now I'm really interested. What are these 3 steps?
We've got low-level formatting. This is the factory reset stuff, like laying down the city grid.
Ah, so this is like creating the basic structure of the city, the blocks, streets, and infrastructure.
Exactly. It's the foundation of our digital world.
That makes sense. So that's our blank canvas. Then we need to divide it up, create some zones. That's where partitioning comes in.
You got it. Partitioning is like establishing different districts within our city.
I like it.
So you might have a dedicated zone for your operating system, kind of like the city center, and then separate areas for your apps and files, like residential and commercial districts.
Okay, that's making a lot more sense now. It's like if the city center has a power outage, the residential areas might still be up and running.
Exactly, and this is one of the reasons why understanding your hard drive can be so useful. Imagine creating a separate partition just for your important files so that even if your operating system gets corrupted, your data stays safe.
It's like having a digital backup generator.
That's a great point. But don't we need to talk about the difference between a partition and a volume? It's easy to get those two mixed up.
Good catch. It's an important distinction. Think of a volume as a larger region that can include multiple partitions. So it's like a metropolitan area.
Exactly. It might include several distinct districts, each with its own purpose.
Okay, so we've got our city all planned out, zones in place, but it's still a ghost town, right? That's where logical formatting comes in.
Absolutely. This is where we lay down the streets, set up the traffic signals, and basically get the city ready for its citizens, your data.
So logical formatting is all about establishing the rules of the road. The filing system that determines how information is organized and accessed.
Precisely. It's like setting up the postal system, making sure every piece of mail gets delivered to the right address.
And without it, it's just a jumble of ones and zeros.
Exactly. Logical formatting is crucial because it allows your operating system to actually make sense of the data on the drive.
It really is amazing when you think about it. We've gone from a blank slate to a fully functional digital city, and we haven't even turned the computer on yet.
That's a good point. Which brings us to the next mind-blowing chapter in our hard drive dump dive, booting up. We all do it every day, but how many of us actually know what's happening in those few seconds?
It's like witnessing the city come to life at dawn. Remember that BIOS we talked about, the city blueprint?
Yeah, like the master plan for the city tucked away in the archives.
Exactly. Well, the BIOS is the first thing activated when you hit that power button, like a wake-up call going out to all the essential city services.
So the BIOS is like the rooster crowing, signaling the start of a new day in our digital city.
I like that analogy. The BIOS starts by doing a quick check on the hardware, making sure everything is in working order. Think of it as a roll call for all the city departments. Power grid, transportation, communication systems.
Okay, so the city's waking up, lights are flickering on. What happens next?
Well, once the BIOS has confirmed that everything is good to go, it needs to find the operating system, the city's mayor, if you will.
Right, the OS is calling the shots, keeping everything running smoothly.
And the BIOS knows exactly where to find it. It looks for a special program called the bootloader, which is typically stored on a specific section of the hard drive called the master boot record, or MBR for short.
So the MBR is like City Hall, where the newly elected mayor takes office.
Precisely. The bootloader takes over and starts loading the operating system into memory, like the mayor arriving at City Hall and getting ready to start the day's work.
And all of this intricate dance of BIOS, MBR, and bootloaders all happens in the blink of an eye.
It's really quite amazing. The entire process, from hitting the power button to the time your OS is up and running, often takes less than a minute. And most of us are completely oblivious to the complexity of what just happened.
I know I am. I usually just use that time to grab my coffee. But speaking of things not going according to plan, let's talk about what happens when our digital city faces unexpected challenges. Like, what happens when a building, or should we say a sector, goes bad?
That's where things get really interesting. Our sources describe this as encountering a bad block, which is a portion of the hard drive that is no longer reliable for storing data.
So it's like a sudden sinkhole opens up in the middle of a busy intersection. What happens then? Does the whole city grind to a halt?
Not necessarily. See, hard drives are designed with a little bit of redundancy built in. They have these things called spare sectors, which are like vacant lots scattered throughout the city.
Okay, so it's like having some emergency backup infrastructure in place just in case.
Exactly.
Yeah.
When a bad block is detected, the hard drive can automatically remap the data to one of these spare sectors, a process known as sector sparing. It's like rerouting traffic around that sinkhole we talked about, ensuring that data can still flow smoothly.
That's pretty impressive. It's like the city's engineers have a secret plan for every possible disaster.
Well, they plan for as many as they can. And there's another trick they use called sector slipping, which is a bit more involved.
Okay, I'm all ears. What's sector slipping all about?
Imagine that sinkhole again. Now, instead of just rerouting traffic, the city decides to demolish the damaged block and shift all the buildings down the street to fill the gap.
Whoa, that's a major urban renewal project.
It is, and that's essentially what sector slipping does. It reassigns the addresses of all the sectors after the bad one, effectively hiding the damaged portion from the operating system.
So it's like the bad block never even existed?
As far as the operating system is concerned, it doesn't. And the best part is that most of the time, these processes, sector sparing and sector slipping, happen automatically in the background without you even realizing it.
That's reassuring. It's like having a team of invisible construction workers working around the clock to keep our digital city running smoothly.
Precisely. But even with the best city planning and emergency response teams, sometimes disasters happen that are beyond our control. That's why it's so important to have a good backup strategy in place.
So we've made our way through the busy streets of our digital city, seen the impressive ways it can fix itself, and even learned why it's essential to have a good backup strategy, like a good insurance policy.
It's been quite the journey. I think it really highlights how much goes on behind the scenes. We interact with our computers at such a surface level, but there's a whole hidden world operating below the screen.
It really is like getting a backstage pass to the most amazing show in town. But this is one show that never stops running.
Exactly. And you know what? Just like understanding how a city works makes you a more informed citizen, understanding the basics of hard drive technology can make you a more empowered computer user.
For sure, like knowing how an engine works doesn't mean you need to be a mechanic, but it sure helps when you hear something weird going on.
Right. This knowledge can help you figure out problems, make better decisions about your storage options, and maybe even recover some data if things go really wrong.
And speaking of storage options, our sources mention some newer technologies that make regular hard drives look like, well, dinosaurs. SSDs, NVMe drives, what are these things?
Yes. Imagine our digital city suddenly upgrading its entire transportation system. That's kind of what it's like moving from hard disk drives, HDDs, to solid-state drives, or SSDs.
Okay, so SSDs are like the high-speed rail of data storage.
Exactly. They don't have any moving parts, which makes them incredibly fast. Like, data access is almost instant.
So that means faster boot times, quicker loading, and a much smoother computing experience overall.
You got it.
Okay, that sounds amazing. Sign me up. But there's always a catch, isn't there?
Well, they are generally more expensive than traditional hard drives.
Right.
And while they are super fast, they do have a limited lifespan in terms of how much data you can write to them.
Ah, so it's like a high-performance engine. You get amazing speed, but it needs a little extra care.
Great analogy. And then we have NVMe drives, which take things even further.
Okay, hit me with it. What makes NVMe so special?
Think of NVMe as the supersonic jet of the data storage world. It's not just a faster SSD, it's a whole different technology.
So we're talking crazy fast data transfer speeds, even faster than SSDs.
You got it. We're talking speeds that were basically unheard of just a few years ago.
It's amazing how fast things are changing. What's next? Are we going to be storing data on microchips the size of dust?
Who knows what the future holds? But that's what makes technology so interesting, right? There's always something new on the horizon. But one thing's for sure, even as storage technology changes, the basic principles we've been talking about, those will still apply.
That's a great point.
And knowing these principles, well, that's what will help you make the right choices as we enter this exciting new world of data storage.
I love how you always bring things back to the bigger picture. It's not just about the tech itself, but about how this tech affects us. Knowing the basics can help us make smarter decisions about the technology we use every day.
Couldn't have said it better myself.
And on that note, I think it's time to shut down our digital cities for the day and give our hard drives a well-deserved break. Thanks for joining us on this incredible trip into the heart of your hard drive. We hope you've gained a new appreciation for the hidden world that keeps our digital lives running. And be sure to check out the show notes for more info on this topic. Until next time, happy computing.
Ever feel like your computer's juggling, like way too much at once? Like seriously, how does it handle all these open apps and files?
It's crazy, right?
Well, get this. Today we are diving into, you guessed it, how your computer keeps everything straight, even when you're like pushing it to its absolute limit.
Ooh, pushing the limits. I like it.
We're talking about swap space.
Swap space.
And trust me, understanding this is going to give you a whole new appreciation for what's happening behind the scenes every time you hit that power button.
It's one of those things most of us just totally take for granted. I mean, we're used to having like a zillion applications open, massive files, and somehow it all just seems to work.
Right, like magic.
Yeah.
Yeah.
But really, there's this super clever system working behind the scenes to make sure your computer doesn't, just have a total meltdown.
Okay, so paint me a picture here. What is swap space exactly? I was looking through our source material for this deep dive,
Yeah.
a chapter from an operating systems textbook, and it calls it an extension of main memory.
Extension of main memory.
Yeah.
Catchy, right?
It's super technical.
It is a little jargony, but okay, think of it this way. Your computer's RAM,
Yeah.
that's like your desk, right? Where you work on all your active projects.
Okay, got it.
But then when your desk gets totally full, what do? You start like stacking papers on a nearby shelf, right?
Exactly.
That shelf, that's basically your swap space. It's like a designated area on your hard drive that acts like basically overflow for your RAM.
So instead of just like crashing when RAM gets full, the operating system's like, hold on, let me just move some stuff over here to the hard drive.
Exactly. You got it's like a safety net, right? Prevents those dreaded system crashes that we all know so well. But, and there's always a but, right? Accessing data on your hard drive is way, way slower than grabbing it from RAM, so it's a trade-off. You get to keep working, which is awesome, but things might slow down a bit.
You know what? That actually explains a lot because sometimes my computer gets so sluggish when I have a ton of apps open, especially if they're like memory hogs, like video editors or something. Is that swap space kicking in?
It very well could be. You're probably pushing your RAM to the limit and your system's like, time to use the shelf.
Makes sense.
And, you might hear the terms swapping and paging used interchangeably. It's a little confusing, but it all comes down to how this whole technology has evolved over time.
Okay, because I was going to say swapping sounds a lot like paging. What's the difference?
So back in the day, like way back, they used to swap entire programs between RAM and this secondary storage. So imagine like clearing your whole desk onto the shelf every time you needed more space.
Oh my God.
Talk about a pain.
That sounds so inefficient.
It was. Thankfully, our systems got a whole lot smarter. Instead of swapping entire programs, they started swapping individual pages of memory. So it's like moving just a few sheets of paper at a time instead of the whole darn stack.
Okay, that's much better.
Right, way better. And that's where the term paging comes in. Much, much faster approach.
So it's like the operating system became this like master organizer, figuring out exactly what it could move around without totally disrupting your workflow.
Okay, so then how much of this magical swap space do I actually need? Is it like RAM, where more is always better?
Ooh, that's the golden question. It's a bit of a balancing act, honestly. Our textbook really stresses that it's always better to like overestimate than underestimate the amount of swap space you need. Because if you run out, your computer's gonna be like, nope, sorry, I'm done. And you're right back to risking those lovely system crashes.
Makes sense. Don't want that.
No, not at all. But on the flip side, having too much swap space can be inefficient too. It's like having a giant shelf you never use. What's the point?
Right, so it's not as simple as just maxing it out.
Not really. It used to be that having double your RAM as swap space was like the golden rule. Oh, really? Okay.
Yeah, but modern systems, they're much better at managing memory now. And Linux, especially, has really, really optimized its approach. So you don't need as much swap space as you might think, especially with the larger RAM sizes we have these days.
It's amazing, isn't it? Like all this optimization that goes on that we never even think about.
It's crazy. But, knowing how much swap space you have and how it's being used, that can be super helpful in understanding your computer's performance, especially when things start to, slow down a little bit.
For sure. So we've got this like metaphorical shelf for all our overflow papers, right? But where does this swap space actually live on my computer? Is it like some hidden folder I'm never going to find?
Not quite a hidden folder. Our textbook talks about two main ways it's set up. It can be like a separate section on your hard drive. They call it a partition, kind of like designating a whole shelf specifically for overflow. Or it can be a file within your regular file system. Like those, those portable drawer units you can get to slide under your desk.
Ah, okay, I see. So two options, partition or file. Is one better? Like pros and cons, give it to me straight.
It wouldn't be a deep dive without some trade-offs.
Never.
Creating a swap file, that's the easier route for sure. Your operating system can just whip one up within your existing setup, no problem.
Convenient.
Right. But, and this is a big but, files within your file system, they can get fragmented.
Fragmented.
Meaning they can end up spread out over different parts of the hard drive, like all over the place. And if your system needs to access that swap space, especially if it's fragmented, well, it takes way longer to gather everything up.
So it's like having your overflow papers not neatly in one drawer, but like shoved in different drawers all over the place.
You got it. And it's just like inherently less efficient. Now, a dedicated partition, on the other hand, that's like having a designated area just for swap space. totally separate. It's way less likely to get fragmented and can even be optimized for faster access.
Makes sense.
But there's always a but. Setting it up usually requires a little bit more, technical know-how.
Okay, so it's convenience versus performance.
Yeah.
Got it. What about flexibility, though? Because our outline mentions Linux. Linux always has a few tricks up its sleeve.
Oh, Linux is all about options. In fact, Linux allows for both swap files and dedicated swap partitions.
Oh, really?
Yeah, so you can have, the best of both worlds. Maybe a dedicated partition for those, predictable, really heavy-duty tasks, and then a swap file as backup for those, occasional overflows.
Okay, that is cool. It's like that one friend who's always prepared no matter what.
Huh.
Okay, but we've talked a lot about, what swap space is, but I'm really curious about the how now. Does it involve some kind of secret code to keep everything organized?
Well, there are definitely algorithms involved, but no secret codes. Our textbook dives into a few, key data structures that Linux uses. So imagine, right? Imagine swap space as this giant parking lot for data.
Okay, a parking lot.
Yeah, a swap area, that's what they call it. And within that lot, you have your parking spaces, right? Each of those is called a page slot, and they can each hold one page of memory.
Okay, I think I can picture this. But then how does the computer keep track of which spaces are taken and by who? Who's parking where?
Exactly. That is where the swap map swoops in to save the day. It's like the parking attendant who keeps track of everything.
I love that.
The swap map is basically like this big chart, right?
Okay.
With a counter for each page slot. If a counter's at 0, that slot's free, come on in. If it's, greater than 0, well, that means the slot's occupied, obviously. And the number tells you how many processes are sharing that specific swapped page.
So it's like carpooling, but for memory. That is so cool.
Right. Efficiency at its finest. Multiple processes can share the same data if they need to.
So smart.
Now, remember how we talked about anonymous memory earlier? Our source mentions that modern Linux and Solaris systems, they mainly use swap space for that type of memory.
Right. Anonymous memory. It's
Yeah.
not tied to a specific file?
Exactly. It's not like data that we're actively working on in an unsaved document, for example.
Okay. Why is it so important for swap space, though?
Well, it all comes back to speed. And remember, we always want to avoid those slow reads from the hard drive, right?
Right.
Even rereading data from the file system is still faster than having to write to and then read from the swap space. So prioritizing anonymous memory for swapping, well, it's just the most efficient option.
So the system knows, it actually knows which type of memory will, benefit the most from being in swap space. So it's like choosing what to put on that overflow shelf strategically.
Exactly. It's all about optimization, right? Making sure your computer is working as fast as possible, as efficiently as possible. But, thinking back to what we talked about earlier with swap space being a safety net, especially to, stop those crashes, back in the day, way back when RAM was expensive, really expensive.
Oh, yeah.
And limited swap space, that was even more crucial then, because it could actually mean the difference between being able to run certain programs or, not.
That makes sense. Back then, computers had a fraction of the RAM that we have today.
Yeah.
So, yeah, swap space, it must have been a lifesaver.
Oh, totally. A lifesaver. But you know what? Even now, even with all the amazing RAM we've got in our fancy modern computers, swap space, it still matters.
Really?
Oh, yeah. It still plays this vital role. It's you have that backup generator, right?
Okay, yeah.
You might not need it every single day, but when the power goes out, you're going to be so grateful that you had it there all along.
That is a great analogy.
Right.
Because it really shows how, even though technology has come so far, some of these basic concepts, they stick around.
Right. They're still super relevant. But it does make you wonder, what's going to happen to swap space in the future? Because think about it. We've got these, ever-increasing RAM sizes.
It's true.
And then there's SSDs. They're so much faster than those old traditional hard drives. And they're, becoming the norm everywhere you look. So what happens to swap space then?
That is the million-dollar question for sure. Is it going to slowly fade out, become obsolete, or is it going to, I don't know, adapt, evolve?
It's really hard to say for sure, but you know what? I think it's safe to say that swap space, it'll stick around. Maybe in a different form, who knows?
Interesting.
Even if it's less about preventing those crashes and becomes more about making sure your system resources are being used in the absolute best way possible, that core idea, that core function, having that extra breathing room for your computer's memory, that's always going to be important.
It really makes you appreciate how much thought goes into making operating systems.
Yeah.
Right? Like, it's incredible how they managed to do so much with the limited resources they have.
Absolutely. For
Yeah.
sure. And, for anybody listening, anytime you feel that little bit of awe because your computer just did something super complicated, but it did it without a hitch, just remember,
Solid pay.
Swap Space deserves some credit for that.
For sure. It's like the unsung hero of the computing world. Well, there you have it, everyone. We took a deep dive into the sometimes murky world of swap space. We talked about its purpose, how it's changed over time, and even pondered its future a little bit. And hopefully you're walking away not just, understanding this vital component of your computer a bit better, but also with a newfound appreciation for everything that's happening behind the scenes to make your digital life possible.
All right, let's dive into this computer storage stuff. You've sent over some fascinating material. It seems like you're really getting into the weeds with this.
Yeah, we're going way beyond just your basic hard drive this time.
Yeah.
We're talking about the core of how computers store and access data. This is going to be a good one.
And that's what I love about these deep dives. We take what seems like a simple concept, and then, bam, a whole world of complexity opens up.
But don't worry, we're going to make it clear. And maybe even a little fun.
I like fun. So where do we even begin?
Well, at the most basic level, there are three main ways computers handle secondary storage. We've got host-attached storage, network-attached storage, and of course, everyone's favorite these days, cloud storage.
Okay, 3 contenders, each with their own strengths and weaknesses, I imagine. But before we get lost in the jargon...
Right, definitions are key. Think of host-attached storage as like your own personal data vault, directly connected to your computer, super fast access, but maybe not ideal if you want to share those vacation photos with the family.
Not exactly built for group projects, then.
Not unless you all want to crowd around the same computer. That's where network-attached storage comes in. Imagine a central hub on your network, a shared data pool that multiple devices can tap into.
So that's our solution for seamless collaboration. Everyone dipping into the same data, well...
Exactly. Now, let's say you need even more storage, a truly massive amount. You could keep stacking up those network-attached drives or call them a cloud
storage, right. It's like having a storage unit that magically expands to fit all your stuff.
You got it. And the best part, you don't even have to worry about the physical upkeep. Someone else is managing all that for you, somewhere out there in the vast expanse of the internet.
Okay, so we've got our contenders. The personal vault, the shared data pool, and the magical expanding storage unit in the sky. Sounds simple enough.
Deceptively simple. Because under the hood, each of these storage types relies on very different technologies. And that's where things get really interesting.
Time to dig into the tech. I'm ready.
All right. Let's start with that host-attached storage. The workhorse here is SATA. You've probably seen those cables connecting your hard drives and SSDs to your computer.
SATA, right.
It's reliable, it's widely used, but it has its limitations, especially when you start talking about serious performance needs.
So if I'm working with, say, massive video files or running applications that need super fast data access, SATA might not cut it.
Exactly. For those scenarios, we often step up to something like fiber channel. Imagine a dedicated express lane for your data that's fiber channel. All about speed and efficiency. You usually find it in high-end workstations and servers.
Okay, so fiber channel is our speed demon. Gotcha.
Yeah.
What about network-attached storage? What's powering those shared data pools?
Well, it actually uses the same language your computer uses to browse the internet, TCP/IP, but instead of fetching websites, it's grabbing files from that NAS device.
Interesting.
And to make sure everyone on the network can understand each other, we have protocols like NFS, for those using Unix or Linux systems, and CIFS for our Windows users.
So it's like a universal translator for storage devices.
Precisely. And then there's ISCSI, which is particularly clever. It's like, imagine you want to speak the language of professional storage devices, SCSI, but you're on a regular IP network. ISCSI acts as a bridge, allowing you to use your existing network to connect to distant storage. It can even make it appear as if it's directly attached to your computer.
Whoa, that's some next-level data teleportation. What about cloud storage? Are we still talking protocols, or does the cloud have its own lingo?
The cloud is all about APIs. Think of them as messengers that allow your applications to chat directly with the cloud storage provider systems.
I see. So why the shift in communication style? Is it because the cloud is, well, cloudy?
In essence, yeah. The internet, by its very nature, is prone to latency, those frustrating delays. And then there's the reliability factor. Your internet connection isn't always as stable as we'd like. APIs are designed to handle those hiccups gracefully.
So if my cat trips over the router while I'm uploading a file to the cloud, it's not the end of the world.
Not at all. The API will simply pause the transfer and pick back up where it left off once the connection is restored. No data lost, no drama.
So we've explored all these different storage technologies, but why should we care about any of this?
Right, because at the end of the day, it's about choosing the right tool for the job.
Exactly. What are the key factors to consider? When comparing these different approaches, I mean, what really makes a difference?
Often it comes down to three things: speed, collaboration, and that ever-important word, scalability.
Okay, so the need for speed, the power of teamwork, and the ability to grow. Let's unpack those, starting with speed. How much does the type of storage impact how quickly I can access my files?
Oh, it makes a huge difference. Think of it this way. With host-attached storage, your data is like a VIP at a concert. Direct access to the main processor, fastest possible speeds.
Front row seats to the data concert. But we talked about how host-attached storage isn't great with scalability. Is that like trying to fit the whole audience into a phone booth?
Pretty much, you're limited by the physical space on your device. Now, NAS, on the other hand, offers a bit more breathing room. You can add more drives to the unit itself, expanding your storage pool.
So a bit more spacious, but are we still dealing with the morning commute data-wise? How does network traffic play into this?
That's the trade-off with NAS. You're sharing that data freeway with everything else on the network. During peak hours, you might experience a bit of a slowdown. It's like streaming a movie when everyone else is gaming online.
Makes sense. A digital tug-of-war for bandwidth. What about cloud storage? Where does that fall on the speed spectrum?
It varies. Remember those latency issues we talked about? Those can pop up with cloud storage, especially with large files, or applications that need instant responses. Imagine trying to have a video call from the top of a mountain. The signal might be a bit laggy.
So maybe not ideal for situations where every millisecond counts. But what about collaboration? How does cloud storage hold up there?
This is where cloud storage shines. It's the ultimate collaboration tool. Sharing files, whether it's with colleagues or clients or your grandma across the country, it's effortless.
No more emailing files back and forth. No more version control nightmares.
Exactly. And because everyone's accessing the same central version of a file, you eliminate that confusion over who has the latest draft. Streamlines the entire workflow.
I can see why it's so popular for remote teams. So in terms of collaboration, cloud storage takes the crown. What about NAS? How does it handle teamwork?
NAS is great for local collaboration, especially with large files. Imagine a team of video editors working on a project. With NAS, they can all access and edit those massive video files without clogging up the main network.
A shared editing bay.
Exactly.
But if you have team members scattered across different time zones...
Yeah, if you've got people all over, cloud storage would be the way to go.
Makes sense. Okay, so we've covered speed, collaboration. That brings us to scalability. Tell me, how easily can these storage options grow with our data needs?
Well, scalability is all about handling growth, and cloud storage is the king. It's like that storage unit that magically expands to fit everything, no matter how much you accumulate.
Sounds convenient, but potentially pricey. Is it like constantly upgrading to a bigger apartment, even if you don't need all the space?
It can be, but a lot of cloud providers offer flexible pricing. You only pay for what you use, like a utility bill for your data.
I like the sound of that. How do host-attached storage and NAS compare when it comes to scalability?
With host-attached storage, you're limited by the physical device. You can upgrade to bigger drives, but you'll eventually hit a ceiling. NAS offers a bit more flexibility. You can add more drives to the unit itself.
So with NAS, it's like upgrading from a studio apartment to a loft. Definitely more room to grow. But cloud storage is more like having a whole skyscraper at your disposal, with the option to add more floors whenever you need them.
That's a great analogy. Now, the material you shared also mentioned SANs and storage arrays, which are more specialized setups.
Yes, I was hoping we could talk about those. They sound a bit intimidating, to be honest. Can you shed some light on these?
Of course. Imagine a private, high-speed freeway system, exclusively for data within a company's network. That's essentially what a SAN, or storage area network, does. It allows for super-fast communication between servers and storage devices, bypassing all the usual traffic of a regular network.
A dedicated express lane for data. I like it.
Exactly. And on this data freeway, you have these things called storage arrays. They're basically sophisticated data warehouses, specifically designed to store huge amounts of information. They come with advanced features like RAID protection.
RAID protection.
Yeah, it safeguards your data if a drive fails.
So it's like having a whole team of data recovery specialists on standby just in case a hard drive decides to take an unexpected vacation.
I like that analogy. RAID ensures that your data is redundant, so even if one drive fails, your information is safe.
That's reassuring, especially for organizations that can't afford any downtime. What about the actual technology behind these storage arrays? Are we talking rows upon rows of hard drives?
Well, storage technology is always evolving. You'll find both traditional hard disk drives, your HDDs, and those super fast solid-state drives, your SSDs, in these arrays. Some even use a tiered approach, using SSDs for the data that's accessed most frequently, provides the fastest performance. And then HDDs handle the bulk storage of the less critical information.
A VIP section in our data warehouse. And the connections within a SAN? Are we still talking about those SATA cables?
For SANs, we typically use faster technologies like fiber channel, which we talked about before, and then there's InfiniBand, which is even faster. We're talking blazing fast speeds.
It's amazing how much technology goes into managing data these days.
It really is. It's incredible.
There's certainly a lot to consider when choosing the right storage solution.
Absolutely. And there's no one-size-fits-all answer. The best approach is to figure out your needs, your priorities, your budget, and then see what fits best.
You've given us a lot to consider. It's like we opened this treasure chest of storage options, each with its own pros and cons.
That's a great way to put it. And just like picking the right treasure, you have to be careful when choosing a storage solution. There's no magic bullet. What works for one person might be a disaster for someone else.
So as we reach the summit of the storage mountain, what key takeaways should we be packing in our backpacks? What wisdom can we take away from this deep dive?
I think the most important thing is to really understand your own needs. What are your priorities? Are you all about speed performance? Then host-attached storage with that direct connection might be the way to go. But if it's more about collaboration, about being able to access your data from anywhere, then cloud storage is probably the winner.
Finding that sweet spot between performance, accessibility, scalability, and of course, budget.
Exactly. And don't be afraid to think outside the box. Sometimes a hybrid approach, combining elements of different storage types, can be the perfect solution. It's like creating a custom music mix for your data.
Now, speaking of customization, I've heard whispers about AI playing a bigger role in data management. Is that just hype, or is there something real there?
Oh, AI is already changing the game when it comes to storage. And it's only going to get bigger. Imagine a world where your storage system doesn't just store your data, but it helps you make sense of it.
It's a fascinating thought. It's like our storage systems are becoming data whisperers, able to understand and interpret the information we entrust to them.
It's an exciting time to be sure. But for now, the best thing you can do is be informed. Don't be afraid to ask questions, do your research, and choose the storage solutions that help you work smarter, not harder.
Words to live by. Well, that brings us to the end of our deep dive into the world of computer storage. Hopefully you're feeling a lot less lost in the data center and a lot more confident about navigating the ever-changing world of data storage.
I hope so. And remember, technology never stands still, so stay curious.
Beautifully said. Until next time, happy data diving, everyone.